Hello, I am Ranbir Kumar, a BTech student at VIT Chennai pursuing computer science with a specialization in artificial intelligence and machine learning. Greetings everyone. Today I am going to present a project that integrates computer vision and fuzzy logic to evaluate shoulder press form in real time using a webcam. The project is titled Shoulder Press Posture Evaluation using Media Pipe and Fuzzy Logic. It's a smart feedback system built using Python, and it uses your webcam to analyze your shoulder press form during gym workouts. The goal is to ensure you are lifting weights with proper form to avoid injury and improve efficiency. In fitness and strength training, form is everything. Even a small error in joint alignment or posture can reduce muscle engagement, lead to shoulder or spine injuries, make your efforts less effective. Traditionally, a form correction is done by a trainer watching and giving feedback. But what if we could automate this? This is exactly what this project does. It works like a virtual coach giving real-time posture feedback. The project combines media pipe pose estimation, a powerful tool from Google that detects key body landmarks like shoulder, elbows, and wrists in real time from camera input, fuzzy logic, SK fuzzy. Instead of hard thresholds, fuzzy logic allows us to evaluate form in a more human-like graded way. For example, an angle of 85 degree might still be good, 65 degree could be bad, and 45 degree is likely bad. This mimics how a human coach would assess your form, not binary but context aware. What does the system evaluate? The system focuses on two main parameters during a shoulder press. Elbow angle measures how much your arms are bent or raised during the lift. Ideally, your elbows should be or above shoulder level at the top of the movement. Shoulder stability. It calculates the vertical difference between both the shoulders. If one shoulder is slightly higher than the other, that means your posture is uneven or unstable. These two parameters are fed into a fuzzy control system which outputs a form quality score from 0 to 100. Live feedback on screen. The system displays real-time feedback as a form score. A colored coded message also appears which indicates good form, bad form, etc. It also visually draws your upper body pose landmarks, including the face to keep focus on the excluding the face to keep focus on the arms and shoulders. Introduction and project goal. This project uses media pipe and fuzzy logic to evaluate your shoulder press form in real time using a webcam. It observes the angle at your elbow and checks if your shoulders are level. Based on that, it gives a form score and feedback like good form, medium form, or bad form. Video capture and pose estimation. We use CV2.video capture to grab frame from the webcam. Every frame is passed into media pipe pose, which estimates the key points on your body. Calculating elbow angle. We define a calculate_angle function to measure the elbow angle at the elbow using the shoulder, elbow, and wrist points. It helps us understand whether your arms are bent enough or fully extended. This uses vector dot to get the angle. The elbow angle tells us if you are lifting properly. A fully extended arm gives angles above 150 degree, while a bent arm might be 60 to 90 degree. We take average from both arms if visible. Shoulder stability on a scale of 0 to 1. To check shoulder balance, we compare the Y values, that is the vertical position of both shoulders. Ideally, both should be level, so the difference should be 0. A big difference means you are leaning or tilting. We subtract the shoulder Y values. If both are at the same height, the difference is 0. We normalize it to a 0-1 scale using 1 difference, where 1 is stable and 0 is totally unstable. The input is used by the fuzzy logic, later explained. Fuzzy logic system. Fuzzy logic helps translate vague human-like rules into math. Instead of saying elbow angle should be 90 degrees, we say if angle is good, the shoulder is stable, therefore the form is good. Elbow angle of 0 to 65 is considered bad, 75 to 180 degrees is considered good, means arm is straight. Shoulder stability, 0 is unstable, 1 is stable. Fuzzy rules. We create rules using fuzzy logic. For example, if your elbow angle is good and shoulders are stable, then form is good. These are human-like conditions turned into logic. Fuzzy system outputs a form score 0 to 100, interpreting form score and giving feedback. Based on this form score, we provide real-time feedback with color and emoji. If the form score is greater than 70, feedback is good form, and the color shown is green. Else if the form score is greater than 50 but less than 70, feedback is medium form, and the color shown is yellow. Else the form is bad and the color is shown as red. Landmark drawing and UI. I also draw only upper body landmarks to help visualize the posture. I ignore the face for clarity. Fallback for missing arm detection. If arms aren't visible due to occlusion or camera angle, we skip calculations and show a message that says arm not detected. Conclusion. This project shows how AI can help in fitness by giving real-time feedback. Student at uses simple logic pursuing computer science with human trainer's specialization in artificial intelligence and machine learning. This is an example, a live demonstration. As you can see, my hands are in bad form. Now they are in medium form. Now that is a good form. Again, good form. As soon as they become in level, they're bad, and now it's in medium form, good form. Again, medium form. This is the level. The score is around 50. As soon as it goes below 50, around below 40, that is bad form. As soon as it goes above 80, it's a good form. Otherwise, it's a bad form if my elbows are not at level with my shoulders or above it. If they're at level, it's a medium form. If they are above my shoulders, it's a good form. Also, the shoulder stability is taken into consideration. As both the shoulders are almost at the same level, it is considered good form, else it's medium or bad form. This is an example, a live demonstration. As you can see, my hands are in bad form. Now they're in medium form. Now that is a good form. Again, good form. As soon as they become in level, they're bad, and now it's in medium form, good form. Again, medium form. This is the level. The score is around 50. As soon as it goes below 50, around below 40, that is bad form. As soon as it goes above 80, it's a good form. Otherwise, it's a bad form if my elbows are not at level with my shoulders or above it. If they are at level, it's a medium form. If they are above my shoulders, it's a good form. Also, the shoulder stability is taken into consideration. As both the shoulders are almost at the same level, it is considered good form, else it's medium or bad form.